Rationalization of binomial surds, conjugate surds. So this is a table that just have an illustration inside this table. So we have surd, we have the conjugate, and then we have their product. So this is the surd. The conjugate of the surd is this. So what is happening is that the conjugate is what will be multiplied by the surd to make it such that their product will give rise to difference of two squares. And you know from generally difference of two squares is simply a plus b and a minus b. So the difference is that the signs are not the same. So if here is plus, it will be negative, and if here is negative, it will be plus. So it can also be a minus b and a plus b. So generally, this will give us a squared minus b squared. Same thing here, a squared minus b squared. So this is a difference of two squares. So whenever our attempt from the last lesson on the rationalization of binomial surds, conjugate surds, I also try to explain that when we need to rationalize the denominator of a binomial surd, we do that by multiplying both sides by its conjugate. Unlike when we have to rationalize a single surd, the denominator of a single surd, we simply have to rationalize this irrational number or surd and multiply both sides by the denominator, which is practically root 3 over root 3 is 1. So you're just multiplying the surd by 1, so to say, because this is both root 3 over root 3 is equal to 1. So in a nutshell, you're multiplying this particular surd by 1 root 3 times 1. But in this case, this 1 is not equivalent to root 3 over root 3. So root 3 over root 3. This is how to rationalize the denominator of a single surd. But for a binomial surd, and I say binomial is that it contains two terms. So for a binomial surd, the denominator is rationalized by using the idea of difference of two squares, and that is to say that you're going to multiply both the numerator and the denominator by the conjugate of the binomial surd of the denominator. So generally, if this is the surd at the denominator, the conjugate will be 2 minus root 3. So when you multiply these two together, you're going to have 2 squared minus root 3 squared. So let's see 2 plus root 3 and 2 minus root 3. So if you multiply this together, this will give us 4. And then 2 times minus root 3, that gives us minus 2 root 3. And then root 3 times 2, that will give us plus 2 root 3. And then root 3 times root 3, that gives us root 9. And root 9 square root of 9 is 3. Root 3 times root 3 equal to root 3 times 3, which is equal to root 9, and that's equal to 3, so you'll get plus 3. Now minus root 3 plus root 3 will be cancelled out. You'll be left with 4 plus 3, and of course, 4 minus 3. And of course, 4 minus 3 are a squared minus b squared. So of course, so then what you have here is 2 squared and then minus root 3 squared. So that's what this part simplifies or implies rather. So this is so initially, so what it says is that if this was the denominator, this is irrational because this is a rational number added to an irrational number, but the product of these two, the conjugate and the surd, will give rise to a rational number. So that's what it means to rationalize, because it wasn't rational in the first place. Initially it was irrational, 2 plus root 3 irrational, but when it is multiplied by its conjugate, which is 2 minus root 3, and we find out how we're going to get is a rational number, which in this case was 4 minus 3 is equal to 1, and 1 is a rational number. So the last term, so if you follow this rule, every surd, the conjugate is the opposite sign of the surd. So if the surd is 2 minus root 3, the conjugate will have the same term but the opposite sign. So here is minus, here will be plus, and if here is plus, there will be minus, but the same terms, same terms, just the sign that will change about the conjugate. So generally the difference of two squares has to do with plus, minus, minus, plus. So that's what it is. So generally, a plus root b will give us a minus root b, and a minus root b will give us a plus root b, a squared minus b squared. The last term is a general expression for surd and their conjugate. We are talking about this last term, which is the product of a surd that is conjugate. It's always the last term is a general expression for surd and their conjugate. So any surd, once multiplied by its conjugate, you always get this to this term, which is the result of the product of the surd and its conjugate. That's the difference of two squares. So also from the table above, from this table, we have seen that the product of a surd and its conjugate is not a surd, which is this. All the time, the product of a surd and its conjugate is not a surd, rather it's a rational number, and its conjugate is not a surd. Since this was an example that was taken to prove that the product of a surd and its conjugate is never never a surd, but rather a rational number. Since a plus root b, a minus root b, when we expand, we're going to have, the process of expansion, a squared minus a root b plus a root b minus root b squared. So minus a root b plus a root b would cancel out. So you're going to be left with a squared minus root b squared, and these two will cancel the square root sign. So you're going to have b left. So to be a squared minus b, which is the difference of two squares. Generally, in solving a given question, sometimes we use one or more of the principles treated above. Solution: simplify 2 plus 3 root 5 squared minus 2 minus 2 root 5 squared. So this is difference of two squares. I'm going to simplify it without using the difference of two squares procedure. So this is first simplify 2 plus 3 root 5 squared. 3 plus 2 plus 3 root 5 squared. This will give us 2. So 42 plus 2 root 5, 2 plus 2 root 5. Since 2 plus root 5 raised to power 2 means 2 plus root 5 should multiply itself. So when it's multiplying itself, the sign will not change. The sign that is here that will also be in the second bracket. So this will give us 2. Then this 2. So the first term in the first bracket will multiply all two terms in the second bracket. So 2 plus 2 root 5 plus the second term in the first bracket multiply two terms in the second bracket. 2 plus 2 root 5. 2 times 2 is 4. 2 times 3 root 5 will give us 6 root 5. Plus 3 root 5 times 2 will give us 6 root 5. Plus 3 root 5 times plus 3 root 5 plus 3 times 3 will give us 9. Root 5 times root 5 will give us 5. 5 times 9 will give us 45 plus 45. So this is 4 plus 45 plus 6 root 5 plus 6 root 5 will give us 12 root 5. 4 plus 45 is equal to 49 plus 12 root 5. And this is the value for this part. So let's do this part next. Simplify 2 minus 3 root 5 squared. So this will give us 2, that will give us 2 minus 3 root 5, 2 minus 3 root 5, equal to 2 minus 3 root 5 minus 3 root 5, 2 minus 3 root 5. That's equal to 2 times 2 is 4. 2 times minus root 5 minus 6 root 5 minus 3 root 5 times 2 will give us minus 6 root 5 minus 3 times minus 3 will give us plus 9 Root 5 times root 5 is 5. 5 times plus 9 will give us plus 45. And this will give us 4 plus 45. Minus 6 root 5 minus 6 root 5 gives us minus 12 root 5. This is equal to 49 minus 12 root 5. So next, since we have gotten a simplified side of simplified is therefore 2 plus 3 root 5 squared minus 2 minus 2 root 5 squared is equal to let me see, 49 plus 12 root 5 equals here 49 plus 12 root 5, which is this value for this square, the square of this surd minus this one. This one here is 49 minus 12 root 5. 49 minus 12 root 5. Let me write it here, and that's equal to 49 plus 12 root 5. Okay, let me write it again. Minus 49. There's no need to put it inside bracket. Minus 49 minus 12 root 5. So it's 49 plus 12 root 5. Minus times 49 gives us minus 49. Minus times minus 12 plus root 5 gives us plus 12 root 5. Yeah. So 49 minus 49 is 49 minus 49 plus 12 root 5 plus 12 root 5. Plus 49 minus 49 give us 0, cancel. So we have 12 root 5 plus 12 root 5 is equal to 24 root 5 as the answer. Number 2, simplify root 75 minus 3 over root 3 plus 1, leaving your answer in the form a plus b root c, where a, b, and c are rational numbers. So this is a binomial surd, and of course we're going to multiply both sides by its conjugate. This will give us, okay, rationalizing. So we say rationalizing the denominator. We're going to have root 75 over, okay, root 75 minus 3, and then root 3 plus 1. The conjugate of root 3 plus 1 is root 3 minus 1, root 3 minus 1. And this will give us root 75. Root 75 times root 3 will give us, so that will give us root 75 times 3. That's root. Let's find out what 75 times 3 will give us. 3 times 5 is 2. 3 times 5 is 15. Another one. 3 times 7 is 21 plus 1, 22. That's root 225. This is too small to contain, so let me write it here. Equal to root 225. Root 75 times minus 1 will give us minus root 75. Minus 3 times root 76. Minus 3 times root 3 will give us minus 2 root 3. Minus 3 times minus 1 will give us plus 2 over root 3. So here's if roots are 2 squared minus 1 squared. So this will give us square root of 225 is 15 minus, we need to reduce 75. 75 is, so the root 75 got the root 25 times 3, which is equal to root 5 times root 3, and that's equal to 5 root 3. So we'll put this in place of the 75 here. So 15 minus 5 root 3 minus 3 root 3 plus 3 will give us square root of root 3 will give us 3, square root of 1 is 1. And this is equal to, so 15 plus 3 is equal to 18. Minus 5 root 3 minus 3 root 3 will give us minus 8 root 3 over 2. When we split this, since the denominator, this is a common LCM, so will give us the common denominators 18 over 2 minus 8 over 2 root 3 equal to 18 over 2 minus 8 over 2 root 3. So 2 here 1, 2 into 18 is 9, 2 here 1, 2 here 4. This is equal to 9 minus 4 root 3. So the question says we should leave our answer in form a plus b root c. So of course this will give us 9 minus 4 root 3. So this is exactly in form we're told to leave the answer in. So we say where a is equal to 9 and b is equal to minus 4 and c is equal to is equal to 3. That's number 2. Number 3, express 5 minus 2 is 10 over 3 root 5 plus root 2. So we say rationalizing the denominator. We have 5 minus 2 root 10 over 3 root 5 plus root 2. 3 root 5 minus root 2. 3 root 5 minus root 2. So 5 times 3 root 5 gives us 15 root 5. 5 times minus root 2 gives us minus 5 root 2. Minus 2 root 10 times 3 root 5 will give us minus 2 times 3 will give us minus 6. Root 10 times root 5 will give us minus root 50. Minus 6 root 50, that's minus 6 root 50. Okay, here's too small to contain. Let me write it here. 5 times 3 root 5 is 15 root 5. 5 times minus root 2 will give us minus 5 root 2. Minus 2 root 10 times 3 root 5 will give us minus 2 times 3 will give us minus 6 root 50. Minus 6 root 50. And then minus 2 root 10 times minus 2 will give us minus 2 root 20 minus 2 root 20. And this will give me 3, it is difference of 2 squares, 3 root 5 squared minus root 2 squared. That will give me. So I'm going to reduce this and reduce this. So I'm going to say for root 50, root 50 is equal to root 25 times 2, which is equal to root 25 times root 2. And square root of 25 is 5. 5 times root 2 will give me 5 root 2. For root 20 is equal to root 4 times 5, which is equal to root 4 times root 5. Square root of 4 is 2 times 2 root 5. So I'm going to rewrite it. So 15 root 5 minus 5 root 2 minus 6 root 50 is 5 root 2. So 5 times 6 will give me 30. So that will give us 30 root 2. Because root 50 itself is 5 root 2. So that's 6 minus 6, 5 root 2. Right, like this. Minus 2. Root 20 is 2 root 5. 2 root 5 over 3. The square of 3 is 9. And the square of root 5 is 5. So 5 times 9 is 45 minus the square of 2 is equal to 2. That's it. So we have next is equal to 15 root 5. 15 root 5 minus 5 root 2 minus 6 times 5 is 30 minus 30 root 2 minus 2 times 2 gives us minus 4 root 5 over 43 is equal to 15 root 5 minus 5 root 2. 15 root 5 here is supposed to be plus yes, minus 2 root 10 minus root 10 minus root 2. So minus root 2 times minus that will give us plus. Yes, plus minus root 2 times minus root 2 will give us plus 2 root 20 plus 2 root 20 plus 2 root 20. So 15 root 5 plus 4 root 5 plus 4 root 5 minus 5 root 2 minus 30 root 2 over 43, and that will give us 15 root 5 plus 4 root 5 is 19 root 5 minus 5 root 2 minus 30 root 2 will give us minus 35 root 2 over 43. So that's our final answer, but we're told to leave our answer in the form m root 2 plus n root 5. So this will give us 19 root 5 over 43 plus minus, you can put it like plus minus 35 root 2 over 43, where plus and minus will give us minus 35 root 2 over 3. That's equal to 19 root 5 over 43. Plus times minus is equal to minus 35 root 2 over 42. I did it this way so that I can conform to what we have here, plus. So this plus is what we have here. So plus times, here it's already negative, and if you split it, you can have your minus 35 root 2 over 43. So minus times plus will be minus. So this is the exact solution. I did it this way so that it can conform to this form here. So, but we're told that the answer should be in the form m root 2. So the 2 should come first, then plus n root 5. So this means we're going to change the order. So therefore, let me say 5 minus 2 root 10 over 3 root 5 plus root 2 is equal to, since m root 2 should come first, that means this is root 2 minus 35 over 43 root 2 plus 19 root 5 over 43. So this is our answer, where m is equal to minus 35 over 43 and n is equal to 19 over 43. Number 4. 4 is 1 over 32 minus 2 root 1 over 8 plus 3 root 1 over 2. Since this one involves subtraction and addition, you just have to simplify as follows. So let's first simplify this to parts. So this gives us 4. That's equal to 4 root 1 over 16 times 2 minus 2 root 1 over 4 times 2, and this will give me plus 3 root 1 over 2. That's equal to, since 16 times 2 is inside the square root sign, that means that it's 1 from our rule, where we say if we have a over b. This will give us square root a plus square root b. So then we have 1 over 16 over 2. 16 times 2. It seems to say that 1 root 1 over root 16 times root 2. Where the square root of 16 is 4. That's root 1 over 4 root 2. That's what it implies. So since the square root of 1 is 1, that gives us 4. 1 over 4. 1 over 4 times 1 over root 2. So that's what implies. Because the square root of 1 is 1. And then this is 1 over 4 root 2. So it will give us 4 times 1 over 4 root 1 over 2 minus 2 times, same thing here, 2 square root of 1 over 4 times 2 equals to 2 times square root of 1 over square root of 4 times square root of 2. That equals to 2 times square root of 4 is 2, 1 over 2 root 1 over 2 over 1 over 2 root 2. 1 over 2 square root of 1 over 2. So square root of 1. So that square root of 1 less than square root of 2. That will be a combined square root of 1 over 2. So 2 times 1 over 2 square root of 1 over 2. Yeah, plus 3 square root of 1 over 2. So 4 year 1, 4 year 1, 2 year 1, 2 year 1. This will give us 1 over 2 minus 1 over 2 plus 3 1 over 2. So this will cancel, since this is plus and this minus will cancel. This will give us 3 root 1 over 2. From but root 1 over 2 is equal to root 1 over root 2. So 3, therefore 3 root 1 over 2 is equal to 2 times root 1 over root 2, where root 1 is equal to 1, so that's 3 times 1 over root 2. Because root 1 is 1, this is equal to 3 root 2. Then we come here and say rationalizing the denominator. Rationalizing the denominator, we have 3 over root 2 times root 2 over root 2. And that's equal to 3 root 2 over 2. That's the final answer. Evaluate 7 over 5 root 1 minus 1 over 15. So the solution is equal to, first I'm going to evaluate, simplify the fraction inside the square root. Is equal to 7, 5 root. The LCM of 1 and 50 is 50. 50 divided by 1 is equal to, so if you make it to over 1, 50 divided by 1 will give us 50 divided by 1 is 50. 50 times 1, 50 divided by 50 is 1. 1 times 1 is 1. So this will give us 7, 5 root 49 over 50. And so this is equal to 7, 5 times root 49 over root 50. And plus this equals 7 over 5 times square root of 49 is 7 over root 50. So what do we do? First thing, I'm going to simplify here. So what this can be said, or okay, let's say 5 times 7 So that's just 7 over 35 divided by root 50. Root 50. So we can write this as 7 divided by 35 over root 50. And of course this is equal to 7 times root 50 over 35. 7 here 1, 7 here 5. So root 50 over 5. That's good. Root 50 but root 50 is equal to root 25 times 2, which is equal to root 25 times root 2. That's equal to 5 root 2. So therefore root 50 over 5 is equal to 5 root 2 over 5. 5 and 1, 5 and 1. That's equal to root 2. Final answer. Number 2. If root 7 is 2.646, evaluate 1 over root 7 minus 1 to 3 significant figures. So 1 over root 7 minus 1. So say rationalizing the denominator. We have here 1 times root 7 minus 1 over root 7 minus 1 plus 1 rather. Multiply both sides by the conjugate. So root 7 plus 1. So this will give us 1 times root 7 is root 7. 1 times plus 1 is plus 1. And this is root 7 squared minus 1 squared. Okay, so root 7 plus 1 over the 7 squared is 7 minus 1. That will give us root 7 plus 1 over 6. But we're told that the value for root 7 is equal to 2.646. So this gives us 2.646. Okay. So we're going to say but root 7 is equal to 2.646. So therefore that's the next thing. So that is equal to 2.646 plus 1 over 6. That's equal to 3.646 over 6. That's equal to 0.608. Question says to 3 significant figures. 0.223 SF. To 3 significant figures. To 3 significant figures. Number 3. If root 6 is 2.45, evaluate without using tables the value of root 2 over root 3 plus root 2. So rationalizing denominator root 2 times root 3 will give us root 6 minus root 2 times minus root 2 will give us 2. Then here will give us root 3 squared minus root 2. Yeah. This is root 6 minus 2 over 3 squared is 3, root 2 squared is 2. So root 6 minus 2, but root 6 is equal to 2.45. 2.45. So root 6 minus 2 is equal to 2.45 minus 2, and that's equal to 0.45 to 2 dp, 2 decimal places. Simplify with 5 minus 2, with 5 plus 2 plus root 5 plus 2 root 5 minus 2. This particular surd is different from a case like this, because this one is a fraction. Two different surds added together, right? This is a single surd. It's a single surd, right? So this is a single fraction. These are two fractions. So I'm not going to, our process of simplification is not going to be through rationalization, like the case would be if it were this case or this single fractional surd. So in this case, we are going to apply the principle of fraction. So if you have 1 over x plus 1 over 2x, of course, that is a fraction. So what you do is look for the LCM of the denominators, which is x, 2x, and then you look for use the LCM to divide the denominator and multiply with the numerator. Then you solve, you see. So here we're going to apply and by this I mean solve to simplify this expression using the method of simplifying fractions. So that tells us, so that means we're going to look for the LCM of the denominator. The denominators is root 5 plus 2 root 5 minus 2. You write LCM root 5 plus 2 root 5 minus 2. So this LCM will divide this denominator. So in dividing this denominator, the two common sides will cancel out. This is common with this. So both of them cancel out. This will be left. So root 5 minus 2 times root 5 minus 2. Here will be root 5 minus 2 times root 5 minus 2 plus 3 LCM again to divide this denominator. This part will cancel this part out. So here will be root 5 plus 2 plus what will be less root 5 plus 2. Question 5 plus 4 9 plus 5 14 plus 4 18. That's 18 minus root 5 minus root 5, that's minus 4 root 5 plus 2 root 5 plus 2 root 5, that's plus 4 root 5 over the square root 5 squared is equal to 5 minus 2 squared is equal to 4. So 18 minus 4 root 5 plus 4 root 5 will cancel out. Minus 4 root 5 plus 4 root 5 will give you 0. So minus 1 will be 18 over 5 minus 4 is 1. So our final answer is 18. So 2 root 2 minus root 5 over 3 root 2 plus 2 root 5. Rationalizing the denominator. 2 root 2 minus root 5 over 3 root 2 plus 2 root 5, and that will give us 3 root 2 minus 2 root 5, 2 root 2 minus 2 root 5, 3 root 2, 3 root 2 minus 2 root 5. Two times 3 will give us 6. 2 times root 2 will give us 2. 2 times 6 is 12. 2 root 2 times 2 root 5. 2 times 2 4. That's minus 4 root 10. Minus root 5 times 3 root 2. That is minus 3 root 10. Minus 5 minus root 5 times minus 2 root 5. That's plus 2. Root 5 times root 5 is 5. 5 times 2 is 10. So plus 10. This will give us 3 root 2 squared minus 2 root 5 squared. 12 plus 10 is 22. Minus 4 root 10 plus 8 minus 7 root 10. 3, square of 3 is 9. Square of the square root 2 squared is equal to 2. 2 times 9 is 18. Square of 2 is 4. Root 5 squared is 5. 5 times 4, 20. So 22 minus 7 root 10 over minus 2, which is 22 minus 22 over 2 plus minus 7 root 10 over minus 2. So this will cancel, and 2 here 1, 2 here 11. So this will give me minus 11 plus 7 root 10 over 2. So 10 over 2, which can also be written as minus 11 plus 7 over 2 root 10. So let's see. So the question says P, okay, given that 2 root 2 minus root 5, 3 root 2 plus 2 over 5 is equal to P plus Q root 10, where P and Q are constants, find the value of P minus Q. So if we compare, our P here is minus 11 and Q here is 7 over 2. So where P is equal to minus 11 and Q is equal to 7 over 2. But that's not the end. We need to get the value of P minus Q. We say therefore P minus Q is equal to, our P is minus 11 minus Q, which is 7 over 2. So let's so make it to 1 minus 11 over the LCM is 2. 2 into 1 is 2. 2 minus 11 is minus 22. Into 2 is 1, that's minus 7. That's minus 29 over 2, which will give us minus 14, whole number of 1 over 2. So final answer. One is 3 root 5 plus 4. Rationalizing. Three times 3 root 5 minus 4 over 3 root 5 plus 4, 3 root 5 minus 4. 3 times 0 root 5 gives us 9 root 5 plus minus 12. So this will give us 3 root 5 squared minus 4 squared. 9 root 5 minus 12 over 9 and 5. 9 times 5 is 45 minus 16. 9 root 5 minus 12 over 45 minus 16. 15 minus 6 is 9. 31 times 2, 29. 9 root 5 minus 12, 29. B 6 over 2 root 3 minus 1. Rationalizing the denominator. Rationalizing the denominator, we are going to have 6 root 2 minus 1, 2 root 2 plus 1, 2 root 2 plus 1. So 6 times 2 root 2 will give us 12 root 2. 6 times plus 1 gives us plus 6. Here this gives us 2 root 2 squared minus 1 squared. So 12 root 2 plus 6 over 2. 4 times 2 is 8 minus 1. 12 root 2 plus 6 over 7. C 2 root 3 root 3 plus 2 over 2 root 3 minus 2. Two times 2, 4, root 3 times root 3, give us 3, 4 times 3, 12. 2 root 3 times plus 2 will give us 4 root 3. Plus 2 times 2 root 3 will give us plus 4 root 3. Plus 2 times plus 2 will give us plus 4. And this will give us 2 root 3 squared minus 2 squared. So 12 plus 4 is 16. Plus 4 root 3 plus 4 root 3 plus 8 root 3. So 2 square of 2 is 4. Root 3 squared is 3. 3 times 4 is 12. And square of 2 is 4. This will give us 16 plus 8 root 3 over 8. So we have 16 plus 8 root 3 over 8, which is also 16 over 8 plus 8 root 3 over 8. 8 here 1, 8 here 2, 8 here 1, 8 here 1. Let's go 2 plus root 3. The final answer. Number 2. Given that 4 minus root 3 over 4 plus root 3 is equal to p plus q root 3, where p and q are constants, find the value of p plus q. 4 minus root 3, 4 plus root 3. 4 times 4, 16. 4 times minus root 3, minus 4 root 3. Minus root 3 times 4, minus 4 root 3. Minus root 3 times minus root 3 will give us plus 3. And here will give us 4 squared minus root 3 squared. 16 plus 3 is 19. Minus 4 root 3 minus 4 root 3 minus 8 root 3. 16 root 3 squared is 3. That will give us 19 minus 8. 19 minus 8 root 3. And then 16 minus 3. 16 minus 3 will give us 13. 13. So this can also be written as, written as 19 over 13 minus 8 over 13 root 3. So now where P and Q are constants, find the value of P plus Q. So that P plus Q root 3. So here from our solution, where P, the value of P is 19 over 13. 19 over 13. And Q equal to minus 8 over 13. Minus 8 over 13. Alright. So, well, the question says we should look for the value of P plus Q. So, therefore, P plus Q is equal to 19 over 13 plus minus 8 over 13. Okay. 19 over 13. Plus times minus is minus 8 over 13. LCM is 13. 19 minus 8. 19 minus 8, 11 over 13. My answer.